and cloud infrastructure. Today, we'll walk you through the project, starting with the introduction to a high-level overview of services, followed by architecture, implementation, and testing strategies. We'll conclude with a live demonstration and finally open up the floor to Q&A. First, I want to start off with presenting our development team, which consisted of myself, who served as Scrum Master and developer, leading the sprint coordination and building core API logic. Giovanni Gonzalez served as our lead QA engineer, responsible for testing strategy, testing, and validating overall system reliability. Mahir Issa was our product owner and database administrator, focusing on requirements, data modeling, and MySQL schema design. Now, for our project overview, our goal was to build a fully functional REST-based healthcare scheduling platform that supported the entire appointment lifecycle, from patient registration to booking, scheduling management, and all deployed in the cloud. A lot of businesses face the problem, often struggle with fragmented scheduling systems and lack of real-time availability tracking. Our solution provides a centralized, scalable API platform that simplifies appointment management and improves efficiency. Our entire source code was maintained in a centralized GitHub repository, as you can see here, that ensures version control, collaboration, and easy deployment. API service overview. From a service description, this system acts as a back-end engine for healthcare appointment scheduling. It manages appointment records, doctor registration, appointment workflows, and easily integrates into hospital portals and mobile apps. From an interpretability standpoint, our API uses REST JSON standards and allows to integrate with almost any front-end system, including mobile apps, web portals, and third-party platforms. From a core functionality, our platform includes the 6 major APIs, which are to create a patient, register a doctor, book appointment, cancel appointment, update status, and fetch doctor's schedule. These support a full read, update, delete operation and form the backbone of our system. For the overall protocol design, we built a system using REST principles over HTTP. Each request is stateless, lightweight, and communication using structured JSON responses. Now, in closing, I want to turn it over to Mahir, and he'll be covering and highlighting tools, technology, and system architecture. All yours, Mahir.
You might be in mute.
Yeah. There you go.
Yeah, thank you, David. Hi, everyone. This project uses a modern tech stack. We deployed our production system in AWS EC2 for hosting in the cloud. And what we did was we use our local developers use their local systems, but final deployment, we have development in the cloud, test in the cloud, and production in the cloud. So it's very accessible to interoperate with customer client GUI applications, as well as multiple types of databases. We're standardized on a Node.js with the Node.js and Express ecosystem for the RESTful API foundation to provide full scalability. Our demo for today will be using the MySQL database for data storage and retrieval, but this can be adapted to Oracle, Microsoft SQL, and other database technologies. Swagger is used for testing documentation standards, including creating YAML dynamic contracts, which are the formal agreement that defines how systems will exchange data with our application. Karate and Postman were used for endpoint testing, and we can incorporate that with the customer's testing needs with your IT team. Karate was used for parallel performance testing, and we've used GPT for agile development acceleration and for filling in any unexpected knowledge gaps. Yeah, for the system architecture overview, this slide shows the full data flow. A client sends a request which enters through our Express server and then moves through the router layer and into the service layer, depending on the type of request, which then they all communicate with the MySQL database for today's demo. The processed result is then returned to the client. Our architecture follows a layered design. Index.js handles incoming traffic, the central connection point for the application service. Routers define API endpoints. Services contain business logic. DB utilities manage database connections. The support and persistence layer, which includes the db.js, config.js, and helper files, help aid in the management of database connectivity. This separation improves maintainability, flexibility, and scalability. For your technical IT team, here's an example of the environment we're in. This slide shows we've used GitHub for the version source, but in terms of the actual structure, you can see here the router folder, services folder, along with MySQL scripts, README text, context. In addition, we've incorporated Swagger documentation for testing purposes for the IT technical QA team. Yeah, so as a product owner, I reached out seriously to with several business stakeholders that are interested in using this API service. We've seriously talked gone into detail with some of the business requirements. We came up with a web solution that can be used by hospitals, private clinics, telehealth startups, and other healthcare platforms needing real-time scheduling and tracking doctor availability for that scheduling. The REST API web service can be interfaced and adapted with various databases and GUI front ends, as I mentioned earlier. Patient registration was our primary objective to minimize patient process delays during the intake process. We had interviewed some patient groups for help prioritize the mobile first registration flow and implemented some data API validation interfaces. For doctor onboarding, we identified some time to productivity key metric issues for patient support administrators. And in addition, the time between a doctor's hire date and the first billable appointment to help with clinic's revenue cycle. Appointment scheduling and management, we focused on retention for scheduling, make it easy for scheduling to happen and to mitigate some no-show appointments as well. We analyzed some of the additional operational efficiency issues as well. For the database schema, we generated here from MySQL reverse engineer the entity relationship diagram. There are 5 tables: patients, doctors, appointment, doctor availability. There's a one-to-many relationship between these 4 tables. I won't go into too much detail in this presentation, but there's questions later we could discuss. There is a standalone users table for future enhancement capability to work with IT with the IT technical teams with their SSO or token authentication. We don't have that in this current demo. And that's it for my part. I'll now pass it on to Giovanni.
All right, thanks, Maher. Yeah, we'll talk about the testing. We use both manual and automated testing. Postman helped validate API functionality, while Karate allowed us to automate regression testing and ensure system stability. This slide will show our execution results, pass rates, and test coverage once finalized. Our goal was to ensure reliability and consistent API performance. For implementation, we built a RESTful app using Node.js and Express, following a layered approach with separate routing, service, and database layers. Swagger was used to define and document the API contract, helping ensure consistency across development and testing. From a testing perspective, we combined manual and automated approaches. I used Postman for functional testing, and Karate was introduced for API automation. Our strategy focused on both positive scenarios to confirm expected behavior and negative scenarios to validate error handling in status codes. On the next slide, I'll show the actual test results and examples for Swagger and Karate and Postman. So you'll see some screenshots coming up here. Here you can see our Swagger screenshots. You can see that we confirmed about the patients and the posts. Here did a good job with this. Next one is the Karate testing. If we have time, we were going to show a live demo of what this looks like on our instance for Karate. Another parallel performance Karate API testing showing the in-depth part that we did to it. This is the Postman manual testing. In addition to automated testing, we use Postman for manual API testing. Postman helped us validate core functionality early on, especially CRUD operations across the doctors and appointments APIs. We executed both positive and negative scenarios to verify status codes, response structures, and error handling. By organizing requests into collections, we were also able to rerun tests easily as the API evolved, which supported basic regression testing. And here we just wanted to show you some of the documentation we did as far as a basic web service contract and some of the documentation we'd done for the Postman. So we had that all for doctors and appointments here. Key challenges and solutions. This slide highlights some of the key challenges we faced during development and testing, along with how we addressed them. One of our first challenges was configuring the EC2 environment, especially security groups and networking on a Windows instance. We resolved that by opening the required ports and validating connectivity using Postman. We also encountered routing issues during testing and during endpoint testing, particularly around incorrect routes and HTTP method mismatches. By standardizing our RESTful endpoint structure and centralizing routing logic in Express, debugging became much more manageable. On the data side, we refined SQL queries to ensure the service layer returned accurate and consistent results. Finally, when setting up automated testing, we spent time learning Karate syntax and parallel execution. By building our test cases incrementally and validating responses with matchers, we were able to successfully automate our API testing. To wrap things up, this project really strengthened our understanding of cloud deployment, RESTful API design, and API testing strategies. From a technical standpoint, we gained hands-on experience working with Express routing, layered architecture, and deploying services on AWS EC2. One of our biggest takeaways was the importance of clearly defined API contracts using Swagger and how combining manual testing with Postman and automated testing with Karate leads to more reliable APIs. Looking ahead, there are several ways the project could be extended, including adding a front-end UI, expanding automated test coverage, and improving scalability. Thank you. We're happy to take any questions. We were hoping to possibly do a live demo if we had time. If not, we can just go to questions.
Let's do a live demo.
All right, let me.
Okay. I can share my screen. Can people see my screen?
Yes.
Okay. Yeah, we were going to do a demo on some of the Postman as well as the karate. I'll go ahead and start out with the karate because that's a little bit more interesting. And then if there's time, we can go to the Postman. So what we've done was just demonstrating here a create patient runtime feature scenarios. So we have here 4, 5 cases scenarios. The first one here is just testing a single patient retrieval from the database through the API using the GET. We also have a second case, and then we do a response check on some of the individual data fields. The next scenario is with just retrieving the full same GET request, but doing a match response to verify the full data record of the patient. And then also doing a full run, retrieving all patients, and then doing just a simple negative test in terms of not validating, not finding particular users' emails in the system, in the patient table. We've also did a create patient feature scenario, just enabling that. So I'll go ahead and run this first set, and then I'll go into the parallel performance test. So the console will load up. And there's 2 ways that normally we use the HTML viewer for the report. There's also the JUnit, which is easier to just quickly verify and see if there's any responses. So in this case, there's 3 positive scenarios passed, and the 4th one is not. If we can pull up the report in the web. Passed and failed, and then any details in terms of time and things like that. And then we'll go really quick. Any questions or on this part? Well, we can probably leave questions to the end. Sorry. Let me go ahead and run the parallel performance test. It's under the Karate API performance folder. Let me pull up the, oh, here's the feature here. This one, very similar. It's pretty easy to set up once you know what the QA person is doing. So it's a scenario outline is the syntax instead of just scenario, and you need to add a table of how many times you want to run the performance test. So in this case, doing the request, I'm doing it 5 times, so there's a placeholder. And so I did that for the same set of responses as the earlier example. Just made those changes and updated the test runner parallel Java file to accommodate for that. So I'll go ahead and run that.
you double click on the test runner parallel.java, what you have inside?
Oh, sure. Yeah, I can go. Yeah, I didn't want to.
Okay, so you're specifying 5 threads. Okay.
Yeah. Yeah, then we'll go to the report, which I believe is under, I always get mixed up with the report. Oh, parallel area. Yeah, so in this case, there's a total, we ran it 5 times and there was 4 test cases. Sorry, there was, yeah, we ran the performance 5 times. We could run it more, but just for the demo. And 5 failed because one of the 4 are the negative tests.
Very good.
Yeah, and then there's a summary of the total times. We don't have any statistics. We were thinking about putting some statistics together of doing that, but we could do that if people are interested. Yep. That's it for the demo. Just to keep it under 15 minutes, I won't go to the Postman.
No, this is really good. So a couple of questions. How long it took to design the Karate as well as Postman automation?
Go ahead, Giovanni, maybe you want to go ahead and speak for the Postman first.
For Postman, I did testing locally, and it probably honestly took me, and I only did the doctors and appointments testing. I didn't do any of the other ones. It probably took me a day and a half, to be honest with you. It was just the negative outcome tests were the ones that I had a little bit of trouble with trying to get correct and putting the right test script or putting the right parameters in. Get all doctors, get all appointments was easy, but it was always those like cancel the appointment. That's like one that was just like kind of throwing me sometimes. But it was just those that were taking me a little while.
Got it. And you mentioned about EC2. So did you guys deploy in EC2 or it ran from local machine? How did you guys deploy your web service?
My hair is in the EC2 instance right now. That's where we put everything
EC2.
to.
Yeah, remote into, if you see the screen here, I could, let me just hide. Oops, sorry, let me go the other way around. Yeah, we're on
Got
EC2.
it. Could you show me your code in that, the service code?
Sure. This is the index one. We can walk through the routing. There's the Swagger. There is Swag. I can go into detail. Let me go into detail with the index one. That's probably the. There's the Swagger configuration, and then we do have the YAML. I could pull up the YAML contract through the browser too, but the code for that. Here's the, using Swagger as the.
Got it.
And then and then we have. Okay.
And then your database is in MySQL, and I'm assuming you install MySQL in your EC2 Windows machine.
Correct. Yeah, I can bring that up.
Okay. So while you were doing that, what did you face any challenge? Like while you're configuring web service layer, database, tables, and all?
Yeah, I did stick with the Windows 2022 server because of, there was some warnings about some of the installations. So I kind of kept it, conservative. I didn't want to run into any installation issues, to keep it as reduced as possible. I did have which I kind of ran down a rabbit hole in a way. I did have a concern with the Eclipse Karate setup, and I tried to go back. There are these problems here, which I wanted to talk to you later offline.
sometimes it's unnecessary warning. Eclipse does have a
Right.
XML and other thing. You should ignore that. If
Yeah,
you
'cause-
only get build error means if you are trying to do build, and if that's the only thing you should worry about. Eclipse is like open source, so each version has some kind of glitches. So just ignore
Yeah.
that. Mhm.
Because I did have a learning curve on some of the message responses, but once I got the hang of it,
Mhm.
there was some issue like there is a map, like the types of data type returned from the service. If you're
Mhm.
returning a single patient, it's a single object. So you need to do a message dot at least a match response dot email. But if you're returning an array or a list, a map list, then you need to use the data one and the data star
Mhm.
to find the match. So that was a little bit confusion. That's where I was concerned about the error originally. But then when I tried it locally on my PC, more simpler cases, I kind of tested more complicated cases initially that I didn't need to install. Like I was installing JDK and stuff like that on the server and changing environment and variables. But
So I
we
hope
did.
you and your group enjoy. So how did you guys communicate?
David, maybe you can go ahead.
And I was
You're the
primarily WhatsApp
coordinator.
coordinating on a day-to-day basis, made sure that we touched base.
So David, like while working with this group, what did you learn more, and what excited you more working with this group?
Just the way that we were able to collaborate with one another. Giovanni was very effective as far as with his testing of it. Mahir did a great job setting up the cloud environment in the EC2 portion to run. And then, guys were just partnering, we thought it would be a larger group, but we were able to get it done with just the three of us. So I like the way that we were able to, throw the ideas off of each other, and they were receptive for any ideas that we had, and we took it and ran with it. So
Wonderful.
Yeah, the timing worked out. Everyone put a good effort, and we were the timing of accomplishing most of the goals was in sync, which we all felt comfortable in, which was we all understood. Understood. Everyone was putting a lot of effort in each of their areas.
Good, very good. So give a big round to this group. This is really good. Actually, you guys did not only done the expected item, but you also added, like example, I like the parallelizations you did, and the way you guys are presented, it looks very good. Giovanni, first time I'm seeing your presentation. Excellent work. I think I can see the confidence in your voice also. Mahir, you did an awesome job about explaining about especially karate parallelizations. I think that was a new aspect, which is data driven. The things you created called data table in the BDD feature file. I think that's a very good. And we have recorded the session for the next group. If they want to, learn from your experience, I think it's always good. And David connecting all the dots and working with the group and creating a very professional, I would say, polished slide. So overall, excellent work.
Can you see my screen?
Yes, we can.
Yes. Hi, good evening. I'm happy to start a presentation of the insurance web services project. We prepared, group 2 prepared this project. And let me introduce our team. Tom, backend development, Node.js, API, GitHub management. Hannah, worked on Postman, Karate, MySQL Workbench, Contract. Carla, testing automation with Postman, Karate, and she created a test plan. Irina worked on documentation, MySQL Workbench, and Postman. Here's the project overview. We designed and implemented RESTful web services for insurance management system, core insurance domains, policies, coverages, and claims. Backend developed using Node.js, data persisted using MySQL, APIs tested using Postman, and Karate automation test. Insurance services overview. All the services were described in a contract, Insurance Platform REST API contract. Policy service included create, update, retrieve, and deactivate policies. Coverage service was for managed coverage types, fire, collision, health, and define limits and deductibles. Claim service was to submit and track insurance claims, update claim status to submitted, approved, rejected. Each service follows REST principles and communicates via JSON. And our GitHub repository will be explained by Hannah.
Oh, thank you. Thank you, Irina. And now I would like to explain how we used the GitHub repository in our project. It was almost first step when we started developing our project after we decided on main project domain. For me, it was very important because it was my first experience using GitHub repository in team, and actually I could say it helped a lot. First of all, we set some rules. First of all, we created this GitHub repository, and everybody cloned it in their local machine. And since then, all our changes we present through this GitHub repository. We set some rules that nobody can merge to main branch until peer review, and everybody should work on their local branches. So it also was new, everything it was new for me, and it's helped avoid a lot of mistakes and not to break our main branch code. So I know it's for me was like a real project because we work in close collaboration with our team. We implement this GitHub tool for our team, and it's helped a lot, avoiding mistakes, reviewing and helping each other through reviewing branches, and also it keep our history of commits. In that way, we can see which changes were done and can reverse them if it was needed. So I'm really glad to have such experience. And now I'll hand it over to our teammate. It's probably Tom.
Yes. Thank you, Anna.
Yeah.
All right. So as far as our application goes, starting with our architecture here and basically covering our design for our Node.js application, we did use specific tools. Primarily for most of our end-to-end testing, we were using Postman. However, we did build a Karate test runner for some automation as well. Our backend was built off of Node.js using an Express framework. And then we used MySQL for setup of our database. The data flow are pretty straightforward for our given project, that we would have a client, whether that's our own front end or another service coming to our web service, hitting us. The web service would gain CRUD information, hit the database, bring it back to the web service, and then to the client. So as you can see with our basic architecture right here is client makes requests to Express server. The Express server sends a query to the MySQL server, and then responses go back from MySQL to the Express, and then from Express to the client application. Now, this is because we are still in the early part of the application development stage, so we would be doing most of our work locally. Our goal state would actually be to use a architectural styling using API Gateway in AWS, wherein the gateway would cover a lot of our backend infrastructure controls, such as the load balancing, going to our different microservices held in AWS Lambda. Clients would, rather than going directly to our public or private IPs would be going through a DNS routing through Route 53. And of course, then our Lambdas would all actually be talking to the same Amazon RDS system that would have replication. So thank you very much. And that is our architecture. I'll hand it off to Carla to go over our test documentation in Postman.
Carla, we are not able to hear you. Carla, we are not able to hear you. Seems like Carla having a technical difficulty. Can someone else cover that content?
Can you hear me now?
Yeah, much better.
I'm so sorry. My headphones must have had a glitch or something. I'm terribly sorry about that. Anyway, where was I at? Implementation, yes. One of our first steps was designing an ER diagram, or an entity relationship diagram, for the policies, coverages, and claims. We implemented the APIs using MVC architecture. And as has been said, we followed the REST methods. Pretty straightforward. HTTP request is made using get, put, post, delete, the basic CRUD responses or requests, and then responses were received from the server in a JSON format. And through extensive debate and testing, we made sure that we had validation and clear error messages just in case of missing or invalid inputs. All right, our testing approach. We used both a manual and automated testing approach. Manual testing was done through Postman, did negative and positive tests. We did a lot for each item, and whenever we get to the demo, you'll see that each thing has a lot of different requests and responses to it. So we made sure our status codes, response times, server errors, all of those were good. And most importantly, made sure that the response returned was what was requested. And for automation, we also did positive and negative tests, and this was very helpful, especially towards the end for regression testing after changes, just to make sure everything was in working order. All right, our total tests executed were 133 tests run. What was that? 50 positive manual tests, 28 negative manual tests, 38 positive automated tests, 17 negative automated tests, and somehow we only had 2 failed tests. Worked out well, but one failure in particular pointed to a potential fault in the code, so that kept it interesting and made it kind of fun. So I am going to pass it off to Hannah.
Thank you, Carla. First of all, I could say we couldn't fully appreciate the power of automation testing with Karate, because it was our learning project, and we took it step by step. So first of all, we created code, then tested manually with Postman, and only after that we started creating automation test. So, but it's hit me, and now I understand why it's so important to start everything from the very beginning, because it could help us a lot during introduction, new feature, new code, to run this regression test and understand that there is so catch earlier some mistakes, and not to try to avoid it with all this automation tests. And also I find that Karate automation is beneficial because it could be fully automated. So in our case, we triggered it with button, but if we would work on our web services further, I would suggest to fully automate it and through for example, GitHub Actions, and implements CI/CD pipelines. So each time when you just introduce some changes in your main branch, it would be trigger these tests automatically. So also I find that Karate automation is very useful and maintainable, because in case you need to change your or URL, for example, there is no need to change, unlike in Postman, every request, change this URL in each request. You just need to change it in one place, and it can save you time and your effort. So yeah, and other benefit that it's has pretty easy syntaxes, so it's human readable, and yeah, it's not deeper. It could be hard, but like simple tests, it's very easy to create. Yeah, but in our case, truth be told, we just go this way. We just take our Postman tests and try to convert them to Karate syntaxes through ChatGPT. So, and that's how we created our, in my case, how I created positive tests, and it's really helped to check if everything worked correctly. Thank you. And we can start with our next slide.
Yes, and for key challenges, learnings, and demo, one of the main challenges we faced was designing a normalized MySQL database that correctly represented relationships between policies, coverages, and claims. Another challenge was handling API validations and error scenarios consistently across all services. We also had a learning curve while integrating automated API testing using Karate alongside manual testing in Postman. So, and now Hannah will tell us what tools and technologies we used.
Oh, it's just a quick review. Which tool we used? It's like Node.js, Visual Studio Code, GitHub, Karate automation test, AI, of course, IntelliJ IDEA, and communication tools like WhatsApp, Google Meet, MySQL for setting database, and Postman for manual API testing.
Thank you, Hannah. And now I'll start the demo. In our demo, just I want to show you real quick what we came up with idea about insurance coverage and claims, created ERD diagram just to see what's going to be in this database. We created the database with tables. We inserted data into these tables in MySQL workbench. Then we created a contract. Okay, contract, I can show it from here. In a contract, insurance platform REST API contract, everything is supposed to be a version, service type, service overview, purpose. The insurance platform API provides endpoints for managing insurance claims, policies, and related operations. This is a learning project demonstrating RESTful API design principles. So in here, we say that we are running this locally, common standards header of status codes, 200 for success, 500 for internal server errors, error response format. So it's going to be one for all services, this kind of format. And then SLA requirements. Forget single claim, it's 100 milliseconds. For list of claims, 300 milliseconds, and just like that. And API endpoints for policy service, all the policy services: get, post, delete, update, and then coverages, 6.2 for coverages. And then we move into claim service. So that will conclude my explanation of the contract, and my team member will tell you more about, Tom will tell you about the code. He'll grab a screen and Tom, can you please share screen to show VS Code?
Yes, thank you very much. I am working on pulling it up right now.
Super.
Thank you. Oop.
Stop sharing.
All right. Is everybody able to see my my screen here now?
Yeah, I can see now.
Excellent. So as far as this goes, we'll just go over quickly what our build here and how we designed our backend infrastructure here. So we did go ahead and use the basic outline that was provided by Tushar previously, and then we moved on from that and continued forward. So we still have the same build structure here of having routes and services. However, we wanted to add in our end-to-end validation as well. So we also have a validation folder here. And then we also went ahead and created some updates to our helpers. So for instance, we wanted to make sure that all of our API errors, all the errors that came forward, came in a very specific format to the user, so that it was always capable to be parsed in a specific way by the user. So we utilize the helper functions here. But generally speaking, the way it's built out is exactly the same as before, wherein we have our route set up. We generally just add it in so that we have all of the different options for get by ID, and post, put, delete. So all of our CRUD operations come in. They hit this point, they get routed into the point of our service, such as with the policies here. And then one of the things that we did want to key in on, that we were working on, is to make sure that we were safe against SQL injection. Now, generally speaking, adding in the string interpolation, as is right here, can leave something open to SQL injection. Now, in the case of these two limit numbers, they are actually integers that are produced by the API and thus not in themselves subject to SQL injection, which is why they are still there as string interpolation. However, the rest of our items were going to be parameterized queries. So we have the parameters coming in this way to make sure that we're safe from SQL injection. So as you can see, what we did is we went ahead and we created policies first. We got all of the CRUD operations working there, and then we split up some work and we got claims and coverages done as well. As far as our validations go, this is where we put in quite a bit of effort to try and make sure that all instances we could think of were handled, such as whenever a create policy comes through, we got to make sure that the customer ID comes through and that it is required to be an integer, but we also want to make sure that they're bringing policy, the required enum values as well. We're getting dates, things such as that. We did also go through and we made sure some of it actually shows up in routes, some of the validation, just to make sure that, for instance, no one is able to send a empty value. That has to kind of get caught before the query point. So it's over in routes. So that's just a basic overview of the way we set up the back end here. Just a normal straightforward architecture for setting all of that up. And with that, I will go ahead and hand off the rest of the demo, which is going to be our Postman and test doc, to Carla.
So got our Postman here. We divided it up into positive and negative tests. I'm going to be focusing just on the policy section because the other sections look a lot like this. And we realized towards the end that maybe we bit off more than we could chew a little bit. So I'm going to go ahead and run the positive tests. All right, let's see. Everything passed. Oh wait, that is incorrect. One failed. Not terrible. The negative tests. I created dummy data to put into the negative tests just because some of them are extremely specific and I thought it was fun. Oh no. I do not want it to run 23 times. Terribly sorry. Try that one more time. There we go. All right. Everything passed there. Yeah, there's even more tests that we could have built out here. Just we didn't test special characters in some of these. We did missing, but my brain exploded with possibilities for tests. But there's only so much time in each day, so we had to kind of limit ourselves to what we could feasibly get done. But I'm very proud of all the work that we've done, and I'm very proud of our group. I think we've done great. I'm going to hand it off to Hannah to show off our karate tests.
I would like to start with how we set this karate project and karate test. So since all other part of our project, it was written all on Node.js, and karate tests build on JavaScript and use JVM. So we should set up Maven environment, and for me it was easier to do through IntelliJ IDEA. So I just created another folder and started a Maven project here. So I also added some dependency for the JUnit testing and for karate. And after that, I already was able to start creating tests and so on. So first of all, I created run classes for running tests. For policy, it's here. For policy, it was policy runner. It's just a runner class that actually start all files under the policy folder, because I didn't specify which exactly files I want to run there. So if I trigger the run test, it will run all tests that is in under the policy folder. So tests I also created in IntelliJ IDEA. So it's pretty simple because it's a pretty simple syntaxes, and it's pretty the same test that was in our Postman. So it's just doubled it, but they are automated. So, and if we go to our karate, so it linked to IntelliJ IDEA. So we have everything we have in IntelliJ IDEA, and when I run my policy runner and it's perform all these tests, I can go to my, oh my God, karate. Wait a minute. So as you can see, all tests passed, and oh no, not all. So something happened, and not all tests, but before, I don't know why it all passed. So I should find out. But anyway, right now we can see that some of them passed in this summary, and some of them not. So also we can go in details and see which exactly test passed, and return and see what's going on with all these tests. So Yeah, it's good to know because karate give us opportunity to see what's really going on right away, right here, and then fix all of this stuff. Yeah, and thank you. It's pretty much I can
Very nice.
say. Yeah,
So,
about
no, this is good. Question, like keep it this slide like this. You mentioned about you converted Postman to karate test case. Can you show us like how did you do through ChatGPT?
Oh, yes, sure.
So this
I
will
just
record the session for others, like if someone wants to try it out.
yeah, I just go to my Postman test, like for example, whatever request, for example, get all policies. So we already have there our tests for Postman. Then I just copy them and go to, for example, ChatGPT. Then to write a request. Please. Oh, sorry. It's. But yeah, you should mention I have, for example, get request.
Very nice. So you know how to write a prompt and you need to do that. Awesome.
Yeah, with such
I think that is
URL.
the art. That is the art now. The using prompt and converting that one from one side to another side. It's art, and that's the power of AI. So excellent that you are leveraging ChatGPT, and I think everyone should do that because this will not only give you speed but also give you quality, because mostly the code is written very nicely. I also use it. I use different tools, but overall great. So while you're converting this thing, Irina, did you learn from this project? Because it looks like you're a wonderful group and seems like you guys did a lot more testing. So how's your learning experience?
I've learned to use GitHub to create my branch or just pull from when Tom updated or Hannah updated or Carla updated something. So I learned to use GitHub. I learned to, actually we all had our assignment. I worked on the coverages, code services and routes. Then I learned to use Postman. So it was pretty cool experience, very deep, I would say. I'm still
Go ahead.
It was a really good experience working with this group. I learned a lot more about code. I have a little bit of experience with it, but it has been years since I've touched it, and it was a little bit of trial by fire for me, but it was enjoyable, and it was good to work with Tom and Hannah and Irina because everybody was knowledgeable in what they were good at and willing to learn about the things that they didn't know. And we were very helpful or willing to help each other out. I got a lot more experience with Postman, which I really liked. I liked doing that. I liked seeing how the tests were run in karate. I'm not to be negative. I am not a fan of karate. I appreciate it. I understand its utility. It was difficult for me to understand, but I definitely appreciated the challenge of it. And I am looking forward to learning more about it. But I'm glad that Hannah in particular was able to pick it up easier than I was. So again, I'm just grateful that we had a good group.
Very good. Tom, how was your experience?
It was good. So I do have a bit more background in some of the stuff. So I took that knowledge and skill to help out everybody by getting the basic portion of the code base done and set up, and then helped out everybody. So because everybody wanted to try it all out themselves, which is, good so that everybody gets skill. So helping out with that. And then and everybody was good to work with. And then honestly, I learned a fair amount here as well. one, it was just good to get back into doing some other stuff that I haven't done in years. As I pointed out with the SQL injection thing, I actually originally made all my queries that were prone to SQL injection. And then I was like, oh man, I totally forgot about that. And that's not a good thing to do. So it was good to catch myself on things like that. And then I don't have very much background in testing, particularly automated testing. I still personally haven't gotten karate to work yet, but it is a good thing to try and get myself some practice in doing and working with, as I have actually helped automate the tests from Cucumber and karate and things like that in the past as the DevOps engineer, but I haven't actually ever written any myself. So very interesting to get my hands dirty in some of that kind of skills that I haven't worked with before.
Yeah, if you need help about how to set it up in Eclipse and all, you can come early tomorrow. We can get it, maybe it will take 20 minutes, because good news, we have a project set up. It's just it's importing that, and if you have Eclipse, should not take longer, because this project which I have done was Eclipse specific, and that's what I use as a seed applications at my work, and it does work.
I mean, I got that one to work when we were doing that. Just, I was using ChatGPT, and I wasn't. I don't think I was converting files right in certain places. And I like to try and find the actual reasoning why behind anything, rather than just trying to get it all to work. So I haven't got it to work, but I know I will. I just need to, take more time and figure it out.